This lecture is going to be on optics. We're going to be looking at different types of mirrors. Here's an example of a plane mirror. Here's an example of a type of mirror that we'll be looking at that diverges light. We're going to call this a convex mirror. We're going to call this one a concave mirror, and we will see that it converges light. And here we'll be learning about a feature of a plane mirror that shows us that we are backwards, left-right reversal. Now we learned about reflection, that we would describe about an incident ray striking a plane mirror. That a couple things that we want to make sure we refer to is draw the normal line. It's always perpendicular to the plane mirror itself. The incident ray comes in at some angle, and the reflected ray exits at the exact same angle in which the incident came in. Remember, these are measured from the normal. So when I look at a plane mirror has a flat, shiny, specular reflective surface. That rays seem to come from behind the mirror, but of course they don't. It is virtually as if the rays were coming from behind the mirror. Virtually means the same as if. As far as the eye or brain system is concerned, the effect is the same as would occur if the mirror were absent and the chess piece were actually located at the spot labeled virtual image. In other words, the top of the chess piece is going to reflect an incident ray. It's going to reflect a ray. It's going to make it to our eye. So we're going to view that as being at the top of the chess piece, whereas the bottom of the chess piece is reflecting a photon that reflects and it makes it into our eye, and then we view that one as being down here. So the virtual image is the image that is viewed as behind the mirror. It's as if light were coming from it, but it is not. Looking into a plane mirror, the image you see in a flat mirror is the same distance behind the mirror as you are in front of it. Since light is not coming from behind the mirror, this is a virtual image. Images in plane mirrors are always virtual. Right side up, same size, and the image distance is equal to the object distance from the mirror. So if this individual here is 1 meter from the mirror, the virtual image is going to be viewed as 1 meter behind the mirror. So they are a total of 2 meters apart. So the left-right reversal. Write out the word ambulance backwards in your notes. You'll see that the reason why ambulance is written backwards is that this individual's right hand, the virtual image, is showing the left hand. So by writing ambulance backwards and you see it in your rearview mirror, you can read it and hesitate, or not hesitate, and move over really quickly. So objects in a mirror for specular reflection. Objects are real physical things that give off or reflect light. Virtual images are formed when many rays on an object appear to come together again. In the mirror, light rays do not actually come together. So if this is a virtual image of the arrows here, if this is the real image of the arrow, so notice it's giving off light. That if this here is the mirror, we view it as being over here, but it's not actually giving off the light. So a virtual image is not real because it cannot be projected. It only seems to be there, and it's always right side up. Whereas a real image is made up of real light that converges at a real focal point, so the image is real. And this can be projected onto a screen because light actually passes through the point where the image appears. And it always appears upside down. So we looked at curved mirrors in class. So what if the mirror isn't flat? Well, we began discussing concave and convex mirrors. That the law of reflection holds for curved mirrors also. That letter A, the image formed in a convex mirror, is smaller than the object, right? There's more area of a viewing range. So in order to fit more stuff in this mirror, everything has to be smaller. Whereas B, the object is close to a concave mirror, so the object is larger when you're closer. Concave mirrors, they're converging mirrors. They have a real focus, it curves inward, and it may be real or virtual. Notice that my concave mirror, light is coming from the left-hand side, which we'll call the principal axis, and it actually reflects and converges into the focal point. Here, you'll see that the focal point, if I am inside this focal point, I see myself as being larger. If I am beyond the focal point, I'm upside down. Well, here's why. Because if I'm inside here, my head would be viewed up here. The top of my head and the bottom of my face would be here. But if I project this and I'm beyond the focal point, here's the bottom of my face, whereas here's the top of my head. So I would be upside down beyond the focal point. And this is my focal length from the focus to the actual mirror surface. Where in a convex mirror, light diverges. It reduces the image or makes it smaller, and it has a virtual focus. They are right side up. Uses. We use these for rear view mirrors. They sometimes says that objects in the mirror are closer than they appear because of the distortion due to being a convex mirror. So light's coming and diverging. It's reflecting and spreading out in all directions. However, the focus is viewed as being behind the actual mirror surface itself, just like a plane mirror. So, which is which? Well, we did these in class, and if you'll notice, my picture here, I'm smaller, so this means this is a convex lens, convex mirror. Ooh. And this, I'm upside down, so I'm within the focal point. Actually, I am upside down, so I would be behind the focal point, of a concave mirror.